This is video number 3 for sections 11.4 and 11.5, graphing hyperbolas. Take a look at this fresh example. We're being asked to sketch a quick graph of this equation. Now what I notice when I look at it is the x is being squared and the y is being squared, so I know it's one of these new shapes from chapter 11. The way that I know that it is a hyperbola is the minus sign in the middle. If there's a minus sign there, it is for sure a hyperbola. Well, the secret to graphing it would be to put it in the right format and then use those results that we came up with in the last video. The correct format is the one where there is a 1 over here on the right side, which I can accomplish by dividing everybody by 16. Very similar to what we did with the ellipse example. On the left, let's see, the 16s cancel out, but I want to still make it look like a fraction, so I would still put that 1 there. The second term does not simplify at all, so I'll leave it alone. And of course on the right, I've created a 1. I've now put the equation in that standard hyperbola format. Let's jot down what we know about it. Probably the first thing I'd want to make note of is this a horizontal hyperbola or a vertical? Well, if the x comes first, x is horizontal, that means this is a horizontal hyperbola. The next thing I should think about is the intercepts. Now, hyperbolas don't have both x and y intercepts. They just have one or the other. Horizontal hyperbolas are only going to cross the x-axis. So this thing will have x-intercepts, and we learned in the last video that the x-intercepts always happen at plus or minus a. Maybe it'd be a good idea to jot down our a and b here. A is the square root of the number underneath the x squared, namely 1. B is the square root of the number underneath the y squared. In this case, that would be 4, since 4 times 4 makes 16. The x-intercepts always occur at plus or minus a. So in this case, that's plus or minus 1. There are no y-intercepts for a horizontal hyperbola, so I don't have to worry about those. The last thing would be the asymptotes. You could write down the equations. We went through that in the last video, but I really don't think that's necessary. All you have to remember is that the rise number is the b and the run number is the a. Rise is up and down. The 4 came from the up and down part, the y part. Run is horizontal. That comes from the x part of the equation. Okay, I'm ready to make the graph now. Let's mark the asymptotes on first. Remember, always start at 0, 0. The rise tells you the up and down. The run tells you the side to side. Mark those dots in all 4 directions. So up 4 and right 1, up 4 and left 1, down 4 and right 1, down 4 and left 1. You can even draw in that rectangle if you like. And then the diagonals of the rectangle are the asymptotes. Looks like we're going to have some steep asymptotes this time. Okay, then I mark on my x-intercepts, positive 1 and negative 1. And then when you draw in the hyperbola, this is going to be kind of a tall hyperbola because the asymptotes are so steep. Remember, the graph follows the asymptotes as x gets really, really large, positively or negatively. And so my final answer is this red solid graph. Everything else that's there, everything I did in blue, is just there to sort of support the final answer and help me figure out what it is. But the red graph is the hyperbola. When you are doing these problems on the homework, just follow the same strategy that I used here. Put the equation in the right format, identify your A and B, make a list of the various features, and you can quickly draw yourself the picture. In terms of my math lab, the graphs are going to be multiple choice here. If you really needed the equations of the asymptotes, you could, of course, easily write them down. We learned in the last video that the asymptote equations are always plus or minus b over a times x, which means in our example here, the asymptotes would be plus or minus, let's see, b over a, 4 divided by 1 would just be 4, plus or minus 4x. But in terms of actually drawing, I think the rise and the run idea with the rectangle is really the simplest way to go.